Assalamu alaikum everyone. Dear students, let's move to the next part of chemical kinetics chapter. In this part, we'll discuss from the reaction mechanism how to find out the rate law and order of reaction by taking some examples. So this question was asked in AIMS. See now, they have given the reaction 2NO2 plus F2 gives 2NO2F. Following mechanism has been provided. Step 1, NO2 plus F2 gives NO2F plus F. Intermediate is formed and it is a slow reaction. Whereas NO2 plus the intermediate combines here and forms NO2F and it is a fast step. Thus, rate expression for the above reaction can be written as. So, looking at the mechanism, you have to give the rate law for this reaction, right? So, whenever you are given the mechanism and when you are trying to write the rate law and finding out the order, okay, few things have to be kept in mind. That is, you have to check the mechanism. Always remember, rate law is taken from the slowest step, right? They will be giving you which is slow step, which is fast step. So based on that, you have to select the slowest step for writing the rate law. Why? Because this slowest step is called as the rate determining step, RDS. Rate determining step is called as the slowest step, or the slowest step is called as the rate determining step, and from that rate determining step only you will write the rate law, and once you get the rate law you will find out the order of the reaction, right? And whenever you are writing the rate law, it should contain species involved in the reaction. It should not have intermediates involved, right? So whenever you are writing the rate law, in the rate law whatever reactants you mention, reactant should be there. You should not mention any of the intermediates formed. If you are getting some intermediate, how that intermediate is related to the reactant, you have to find out by applying equilibrium concept. Then you will write the correct rate law. Okay. Okay, first we'll go with this one, as this is the slowest step. Easily you can write its rate law, because in this slowest step NO2 is there, NO2 is the reactant, F2 is also there, F2 is also a reactant. So these reactants are there. It does not have any intermediate now. Intermediate is here, but it is a fast step, right? So always rate law is written by considering the slowest step, because slowest step is the rate determining step. So what will be the rate law here? We'll be writing the rate law as R is equal to K. Whatever balancing coefficients will be there in this slowest step, the same you will be making as the power, right? So here it is nothing but 1 is there. So you will be writing NO2. Next reactant is F2. Right? NO2 and F2. So this is the rate law. So the correct answer will be B option. Okay. And what can be its order? What is the power here? 1, and here also power is 1. So order here is 2. Okay. Next question. Possible mechanism for the reaction 2H2 plus 2NO gives N2 gas plus 2H2O is. They have given the mechanism. Initially nitric oxide is converting into N2O2, then N2O2 is the intermediate. Why intermediate? Because it is not at all present in this reaction. Okay, reactant side as well as product side, it is not available. So N2O2 is an intermediate. What are intermediates? The unstable species formed during the reaction, and they are consumed during the reaction itself. Okay. In second step, N2O2 is combining with the other reactant to produce N2O plus H2O. Right? Again N2O plus H2O. N2O is again a intermediate, right? N2O plus H2 is giving you N2 plus H2O. So three steps they have given. They are asking what is the rate law for the reaction, and one more part what they are asking, the order of the reaction, right? So to find out the rate law, which step we have to check? We have to check the slowest step. Which slow step is there? This one is treated as slowest step, right? And the step which is under equilibrium is this one. They have mentioned with equilibrium sign. This step is under equilibrium. This elementary reaction is under equilibrium, whereas this is slow step. So nothing but it is the rate determining step. Okay. So from this rate determining step, you will write the rate law. Rate R is equal to K molar concentration of N2O2 into molar concentration of H2. But here N2O2 is neither the reactant, because reactants we have H2 and NO, whereas you are getting N2O2, it is not available in the overall reaction. So N2O2 is an intermediate. So you can't write the rate law where intermediates are present in the expression. So you need to find out how this N2O2 is related with the reactants. So for that sake, you have to consider the equilibrium expression, this one, right? So using this reaction, you can find out how this N2O2 is related with NO, right? As it is under equilibrium, we can write its equilibrium constant. Equilibrium constant is nothing but ratio of molar concentration of product to the molar concentration of reactant. So K equilibrium is equal to molar concentration of N2O2 divided by molar concentration of NO raised to 2. From where you are getting? From this reaction, right? Now you are going to find out how this molar concentration of N2O2 is related with equilibrium constant and NO, right? So N2O2 is equal to K equilibrium constant into NO raised to 2, right? So you got the value of molar concentration of N2O2 is equal to K equilibrium into molar concentration of NO raised to 2. This part you have to substitute here, right? So you should not write N2O2 here. Instead of that, you have to write how it is related to NO. You have to write, find out and substitute here. So the rate law actually becomes K is equal to R is equal to K into K equilibrium NO raised to 2 into H2, right? So this we write it as K dash or simply K. Both are constants. We write it as K NO raised to 2 into H2. So this is the rate law for the above reaction. Okay, this is the rate law for above reaction. So first part is over. Okay, what is the order of the reaction? So order of the reaction will be sum of the powers on the concentration terms in the rate law. 2 plus 1, that is equal to 2 plus 1, that is equal to 3. This is nothing but order of the reaction. Okay, so this is the way you have to solve. If you are getting an intermediate in the rate law, select the reaction which is under equilibrium, relate it with equilibrium constant, the product and the reactant concentrations, and find out the intermediate, because as this is the intermediate, you will find out how this concentration of this intermediate is related to other reactants. Okay, next question. This question was asked in 2017 NEET. Mechanism of a hypothetical reaction. X2 plus Y2 gives 2xy is given below. X2, this should be taken as under equilibrium, and this is a slow step. This one is fast, this is slow. and x plus y, xy is fast. Overall order of the reaction they are asking, right? So to find out the order, you must write the correct rate law. Once you get the rate law, then you will write the order of the reaction, right? So to determine the order, to determine the rate law, what you have to select? You have to select the slowest step. Which is a slow step here? This one. Rate determining step is this one. So you will write the rate law using this rate determining step. What will be the rate law? R is equal to K molar concentration of X into molar concentration of Y2. This will be the rate law. But here X is coming where we don't have X in the reactant side. So X is intermediate. It is intermediate formed during the course of the reaction. So what you have to do? You have to find out the relationship of this intermediate with the other reactants. How? By applying the equilibrium concept. So using this equation, we can find out what is the value of X, right? So equilibrium constant for this reaction, we can write it as K equilibrium is equal to molar concentration of products into divided by molar concentration of reactant. ओके ये इक्वेशन देखो, ये दोनों प्रोडक्ट है. So molar concentration of X into molar concentration of X divided by reactant is molar concentration of X2. Okay, nothing but K equilibrium is equal to molar concentration of X raised to 2 divided by X2. X की वैल्यू पता करना है तो क्या होगा? X raised to 2 is equal to equilibrium constant molar concentration of X2 or X is equal to square is there. If you take on the other side, it will become square root, or we write it as K equilibrium molar concentration of X2 raised to 1 by 2. Square root is nothing but X2 raised to 1 by 2. So now you got the value of X. In terms of X2, how it is? X2 raised to 1 by 2. X2 is there in the reactant. X2 है, Y2 है. आपको X की वैल्यू मिल गई अभी. ये वैल्यू आप X की यहाँ पे सब्सटीट्यूट करेंगे. So what you will be getting? R is equal to K into K equilibrium molar concentration of X2 raised to 1 by 2 Y2 as it is. Okay, so this together we write it as K molar concentration of X2 raised to 1 by 2 molar concentration of Y2 raised to 1. This is the correct rate law. Okay, so order with respect to X2 is half, order with respect to Y2 is 1. Okay, so overall order of the reaction will be what? Order is equal to half is 0.5 and Y2 order is 1. So 1.5 is the overall order of the reaction. 1.5 is the overall order of the reaction. So option C is correct. Okay. One more question of the same type. Chemical reaction 2O3 gives 3O2 proceeds as follows. O3 dissociates to produce O2 plus O, fast step, and O plus O3 gives 2O2, it is the slow step. Rate law expression should be, right? Again, you have to write the rate law. Rate law is found out from the slowest step. So this is the slowest step. Looking at the slowest step, you have to write the rate law. If it contains some intermediate, you have to find out what is the value of intermediate using the equilibrium concept. Okay, so this reaction, first reaction is under equilibrium. Okay, तो पहले रेट लॉ लिखेंगे. R is equal to, कौन सा इक्वेशन देखना है आपको? सेकेंड स्लो स्टेप जो है उससे आपको जो है रेट लॉ लिखना है. K क्या क्या रिएक्टेंट है यहाँ पर? मोलार कॉन्सेंट्रेशन ऑफ O and molar concentration of O3, राइट। अब रिएक्टेंट साइड ओवरऑल रिएक्शन में सिर्फ ओजोन है, O3 है, यहाँ पे आपको जो है O भी आ रहा है। सो रेट लॉ लिखते वक्त रिएक्टेंट्स आना है और रिएक्टेंट सिर्फ O3 है, ये नहीं होना है। तो आपको ये टर्म भी आपको जो है O3 फॉर्म में लेना पड़ेगा, राइट। कैसे लेंगे? फर्स्ट इक्वेशन देखो आप, you look at the first equation, then you will get the correct value of O. So you will apply here the equilibrium constant expression. So what will be that one? We'll be writing K equilibrium is equal to molar concentration of O2 into molar concentration of O divided by molar concentration of O3. From where you are getting this one? From this equation. Okay. So you have to find out what is the value of O. So molar concentration of O will be equal to K equilibrium multiplied by O3, ये इधर आ जाएगा, and O2 will go down, divided by molar concentration of O2, right? So you got the value of intermediate, that is equal to K equilibrium into molar concentration of O3 divided by molar concentration of O2. So that you can substitute over here, because either of the reactant or product should come in the rate law. Okay, so I'll write K into K equilibrium, O value is O3 divided by O2 into, as usual, this one O3. So this together I'll write it as K dash, or simply I'll write K, O3 into O3, O3 is raised to 2 divided by molar concentration of O2. Okay, or K is equal to molar concentration of O3 raised to 2. If we मोलार कॉन्सेंट्रेशन ऑफ O2 रेज टू 1 है, न्यूमरेटर में ले लो, तो क्या हो जाएगा? मोलार कॉन्सेंट्रेशन ऑफ O2 रेज टू -1 हो जाएगा, राइट। सो दिस इज द रेट लॉ you get for this mechanism or for this reaction. So correct option will be R is equal to K, O3 raised to 2, O2 raised to -1, option B. Okay, order कितना होगा? 2 minus 1. 2 minus 1 is 1. Order for this reaction is 1. How you are getting 1? Concentration term O3 power is 2 and O2 power is -1. That is equal to 1. Right? So this is the way you have to find out the rate law and order if you are given the mechanism